So next, I'm going to use Google's Colab. I'm a pro member, which I recommend, though I don't know if I always take enough advantage of it, but I have it. And Google Colab, if in case you don't know, is basically like a Jupyter notebook, though I think it has some extra features and usability that I like. And one of the great things about Google Colab is that it is tied to your Google Drive. So this notebook, this IPNB notebook, is saved in my Google Drive. So since I'm always using Google products like Gmail, having this sort of at my fingertips makes it easier. So the first thing I'm going to do here is I'm going to show you the libraries that I want to install. So um, Google Colab comes with a lot of libraries pre-installed like NumPy, Pandas, sklearn, SciPy, etc. But I want to install CapBoost, which is a gradient boosting algorithm. So it's another gradient boosting decision tree based algorithm. This is category encoders, which I will not really use that much, though I'll mention it, but it's basically for encoding categorical variables. And as we saw before, all 16 of the 17 features are categorical. In fact, they're just 1, 0, right? They're binary, but they are categorical. SHAP is to install the library that will help you look up SHAP values, which is a sort of model agnostic way of explaining feature importance. And that is something that I'm not quite sure is really talked about in the original paper. So there are things here that sort of may go beyond the scope of the paper. I will spend some time trying to compare this to what is in the paper, um, you know, and but anyway, that's later. This Bayesian optimization is one of many libraries like skopt and whatever that are for optimization. In this case, we're interested in hyperparameter optimization and of our various learners. So, because every single one that I'll be using, whether it's um, especially the gradient boosting types, are basically going to need some kind of optimization. So, random forest, decision tree, support vector classifiers, that kind of stuff would benefit from a little bit of hyperparameter optimization. So basically, I'm going to then, this is Google Colab's import. So you want files so that you can upload something and then Drive in case you want to like save something or load something from Google Drive. Everything else here is pretty standard. NumPy is MP, Pandas is PD. Um, Bayes.opt, you want to import Bayesian optimization. From CapBoost, LightGBM, and XGBoost, you want to just import everything because you want to use their classifier. And here for sklearn, I have Bayes in case you want to use the naive Bayes classifier. Ensemble for random forest. Neural network I didn't really use, but I could have used for the multi-layer perceptron classifier, the MLP classifier. This is for decision trees. I repeated this. Linear is ridge classifier, that kind of stuff, or logistic regression. Model selection is so that you have your train test split and your cross validation. Metrics is so you have metrics for error measures of your model. So you're talking about things like the F1, precision, recall, accuracy. Error. In my case, I'm going to really focus on the Matthews correlation coefficient. And then SVM is so that you have support vector stuff like support vector classifier. Okay?